Good morning, classes. It's Friday, first week after spring break. We got a few more to go. Hey, we're going to be looking at lateral and surface areas of pyramids, and then Monday we'll take a look at lateral area and surface area of cones. But the pyramids look like this. I've got a picture in front of you. This is a pyramid, like the pyramids of Gaza. Anyway, the pyramid, it's a regular pyramid. Notice down here, I'm circling the word regular. Regular just means it's going to be a square, or all the sides are the same. All of the sides of that base are going to be the same. So if it was a regular hexagon, all 6 sides would be the same. If it was a regular octagon, all 8 sides would be the same. Due to the time of the COVID crisis and stuff, we're only going to be looking at square rectangles. So these are all rectangles that are going to be looking like this one. You'll notice that I marked this orange over here. Orange, you glad I did that, as L. That is called the slant height. L is referred to as the slant height, okay, which is the height of the face. Now notice the face is on a tilt, okay. The actual height of the pyramid is the yellow, and that would be what I marked as an H. You'll not see that in the formula here, but if you notice, H and L, and then I drew a little half line into the center there, down in this point right here. Notice that makes a really cool right triangle. Okay, so we have this right triangle available to us in the middle there. And we will take a look at that later. The surface area then, the total surface area, is just going to add to it the base. So we will add the blue base. Now I drew a little net down here, and this is kind of what the net would look like. It's a sketch. No, it's not good. There are four sides of the red triangles, which then would make the upper part, or the lateral area. That's this piece right over here. The lateral area is the red. Okay? And the adding in the blue, now it's the red and the blue, red plus blue, and that gives us then the surface area. All right, we're going to bypass this one. This is a hexagonal pyramid. We'll bypass that, and we're going to go down here to one that it says draw. Okay, so a square pyramid has base edges of 5 meters and a slant height of 3 meters. What is the surface area of this pyramid? Well, to find the surface area, I've got to find the lateral area as well. So remember that our lateral area is 1/2 times perimeter times L, as the formula said on the last screen. Back up a little, and there it is. LA is 1/2 times PL. P being this red area all the way around. It's the line all the way around the base. So it's the exterior, or the fence around the base, if you will. It's the perimeter, okay? And then the L is the slant height, as we said earlier. Okay, so LA is 1/2 times P times L, whereas surface area then adds the LA plus the base. Okay, so we already know that L is 3, so we're going to go ahead and put L is 3 over here, 3 meters. And we're going to say the perimeter is the sum of all 4 sides here. Well, here's 5, that would be 5, and this would be 5. And so the sum would be P is 4 times 5, or 20 meters. Okay, and that's a linear measure, so it's not squared. All right, the LA then would be 1/2 times 20 times 3. Well, 20 times 3 is 60. Half of 60 is 30. So the LA is 30 meters, and this is going to be squared because we got meters times meters. All right, now we got to find the base. Now the base is right over here. Well, that would be this whole area down here. Okay, so base is 5 times 5, or 25 square meters. Okay, the surface area then is the LA, which was 30 meters squared, plus the base, which was 25 meters squared, which gives us a total of 55 meters squared, and that is our surface area. Okay, it's a hollow box or a hollow triangular shape that has a clip-on bottom on it or base. So it's hollow inside of there. We're just looking at the wrapper on the outside. Okay, that's a square pyramid surface area. If they wanted you to know what's the lateral area, see, you could stop right there. There's the lateral area, and this is the surface area, the total. It adds the lateral area plus the base. Okay, the next one we're going to take a look at is a pyramid that was actually in Rome, Italy. Now, they've got the picture of the pyramid over here. It has a height of the pyramid is 36.4. And we want to know what's the slant height, because the slant height is in the formula up here with the lateral area. So we're going to actually take that triangle I had referred to earlier, the right triangle, which has the height and the slant height in it, and then half of the base because it goes to the central point. All right, well, notice that the base over here was 30 meters. That means that half of that would be 15 meters. Okay, so you got 36.4 meters and 15 meters. Now, if I recall right triangles, if you use the Pythagorean theorem, which is a squared plus b squared, or short leg plus long leg squared, short leg squared, long leg squared, so that would be 15 squared plus 36.4 squared equals the hypotenuse, which is BA, but we're going to go ahead and call that L squared because that's what we wanted. We want to know what is that L. And this is L, and L is also this one, or BA. Well, we know that 15 squared is 225, and 36.4 squared is 1324. That's not coming out very good, is it? Having a hard time here getting my letters. 1320, there it goes. 1324.96. And that's going to be L squared. When I add those together, I'm going to get L squared is 1549.96. And then to find L, that is the square root of that. So we take the square root of the 1549.96, and we are going to get about 39.369. We're going to rough it to 39.4. Now, we didn't round that to the nearest square meter on this because we want to round our final answer to the nearest square meter. Okay, this would be the nearest meter, and that's linear. So we'll just leave it at 39.4 for the moment. All right, and the LA is 1/2 times the perimeter. Well, now remember, the perimeter, let me go a different color here. The perimeter is the wrap all the way around. It's that perimeter around the base. Well, if each side is 30, it's regular. Each side is 30, so 30 plus 30 plus 30 plus 30, or 4 times 30, is going to be a 120. So we're going to take our 120 times the slant height, which we just found, 39.4. Half of 120 is 60, so that gives us 60 times the 39.4, and 60 times 39.4 is going to give us an LA of 2,362. Now I'm going to round it to the nearest square meter. So 2,362 meters squared. There's my LA. All right, I'm going to go ahead and mark that in green. All right. And then I'm going to take my SA, surface area, and we will add to that 2,362 meters squared, the base. And base is going to be 30. The area of the base would be 30 times 30, or 900. So we'll add to that the 900. meters squared, and that would give us then 3262 meters squared for the surface area. All right. Problem asked for the lateral area. I threw in the surface area there because I only had 2 examples. I hope that gives you at least a little bit of a lead into how to do these problems. Again, they are only square pyramids. Hope you have a good weekend, and we'll talk to you later. Have any questions, give me a holler. Bye.